Everybody, we're going to go ahead and get started here. I'm going to try and use every single minute of my allotted hour. Just FYI, this is pretty much an unabashed AWS advertisement, and I'm not here to sell you anything. If you end up using more AWS, that's great. If you don't, that's also great. But what I want to do is I want to recap all of the announcements that we made in 2018 at our annual conference called reInvent in Vegas. How many people have been to reInvent before? How many people are really tired of going to Vegas all the time? You could not pay me enough money to step foot in Vegas again. But I'm a software engineer. I'm not like sales person. I don't get commission or any of this other nonsense. So I'm going to try and be as real about the services as I can. But I do have to toe the corporate line and hit all the different PR talking points. But don't worry, I'll click through those as quickly as possible. So for those of you who haven't been to reInvent before, it is a giant conference. There are 50,000 attendees. We have 100,000 people plus watching on the live stream. And we have 2,100 different breakout sessions. This covers everything from building a global internet backbone. And as I learned recently, we have to use special cabling in different locations because there are termites in Australia that eat plastic because Australia. And you learn about all these different things. And you have things like a Harley ride. And you have, I don't know, Midnight Madness, where that's me. And you get to like hang out with this ninja, and who knows, it's just like crazy stuff, a wing eating competition. We had the cast of Portlandia come and hang out with us, and then you have like hands-on labs and all this other stuff, Jassy's keynote, Werner's keynote. And then the most important part is the replay party. So if you go to reInvent and you don't go to the replay party, you've really kind of missed out on the whole experience, because we have Skrillex come or you know, some other EDM DJ that is basically just bass notes assaulting your senses. And you get to experience hundreds of thousands of people dancing and jumping around, because apparently that's fun. You can tell I'm an engineer, maybe. So I wanted to say this is going to be really, really fast. We had more than 100 different announcements and across a whole slew of different verticals. This is my second time coming to VTUG, and I just wanted to give a quick thanks for inviting me back. Prior to working at Amazon, I worked at SpaceX and NASA, and then I found out physicists don't make any money, so I went on LinkedIn and I changed my title from physicist to software engineer, and I got a ton of recruiter spam, and I got a real job. And then I think JavaScript is basically mass psychosis, and Python is pretty good. I don't like white space as a delimiter, and this is my official badge photo. And they asked me if I wanted to change it, and I was like, nah, I think I look great. So now you know a little bit about me. I've spoken with a couple of you before, and I wanted to say, my email address is going to be at the end of this. Any questions you have about AWS, I'm more than happy to answer those questions, even the ones that I have never really gotten around to answering. My email backlog is several thousand people long, but I do get to it slowly but surely, except for the one time where I didn't. I'm really sorry. I totally remember. We did release a nice feature that I'll tell you about in a little bit that might be useful for you. OK, so what I'm going to cover, we're going to cover a business update. We're going to go over our global infrastructure. I'm going to talk a little bit about the internet backbone that we've built. This includes transatlantic, transpacific, cables, internet exchange points that we've invested in, and all kinds of different things that we're doing to improve the internet worldwide. Different cabling projects that we have going on in the Atlantic and Africa. And these are really, really cool pieces of technology. These are oil-insulated cables anchored to the bottom of the sea. It's just massive, crazy, cool technology that goes into making these. And then we're going to talk about the compute infrastructure. We're going to talk about some security and hybrid cloud stuff, which is what I think the attendees at VTUG might really be interested in. We're going to cover storage and analytics. We're going to talk about databases, which is one of my favorite topics. And we're going to talk about AI and ML. And it's also one of my favorite topics. And we're going to talk about IoT, which I don't really care about. And then we're going to talk about some new business initiatives involving robots and space. Those are the new business initiatives. We actually started attaching satellites into each one of our regions. So you have, if you want to pull data directly from low Earth orbit or even medium Earth orbit satellites, you can say, hey, I want to put this in S3 afterwards. So if you have enough money to launch a satellite, talk to me. We should be friends. Or adopt me. So business updates. AWS is a $27 billion revenue run rate company. This is a massive company, and it grows 46% year over year. It's far and away the market leader. We have a couple of really, really fun competitors who are really kind of coming into their own now and building lots of cool stuff. I would recommend you check out their stuff too. Again, I'm not trying to be AWS biased, but we have been doing this a lot longer than the rest of the folks out there, and we have gotten some experience. And there's really no compression algorithm for experience, as our CTO is fond of saying. So when we launched reInvent in 2018, we asked the question, what do builders want? What do software engineers want? What do architects want? What do people want to be able to do and build? And the answer to that question was they want the broadest and deepest cloud platform for themselves. They want to be able to think of something and build it without having to go and make long-term contracts or discussions or any of this other nonsense. And to that end, I want to give you some background about how AWS works. So the clouds that we have currently spans 20 geographic regions, and we've announced 4 different additional regions in, I'm going to get this wrong, but Italy, Bahrain, Hong Kong, and South Africa. And then we launched one in Sweden, and don't worry, we didn't bury that one underwater. It's a cheap dig at one of our competitors that built a data center underwater because supervillains, I guess. Anyway, AWS regions are geographic points on a map, and availability zones are the subdivision of those regions. And what that looks like is you have regions like this, Northern California, GovCloud, and Montreal, and London, and all this other stuff. And each one of those regions contains multiple data centers that are connected with extremely redundant network capacity that is just, it's mind-blowing how much capacity exists between these. I think in one of these locations, we have something like 300,000 servers and 388 unique fiber paths. One of the cool things that we do with these fiber paths is we actually measure, we know the exact way these paths are laid down. So we have a metal core in the 2-inch conduit, and we go and we know the exact path that it takes, and we measure down to the millimeter, actually sometimes more than that, exactly how far those are going. And if we start seeing light loss, if we start seeing delays or issues in propagation, we can do the math based on the speed of light to figure out where exactly in the cable that fault lies. And back in 2016, James Hamilton went on stage at reInvent, and he announced this cable, which is a standard 2-inch conduit that holds, I think, 3,456 fibers. And we've actually taken that a step further, and we've kind of re-engineered that core cabling to fit 6,912 fibers, that's the one on the right, into the same 2-inch conduit. And again, in Australia, because giant mutant termites that eat plastic, you have to use a completely different coating. I only learned this on the flight here. I took the red eye from California. It's much sunnier and warm there. How do you guys live here? It's like, I don't, it's so wet, and I guess it's not really cold right now. It's 50-some degrees, but it's warm. So again, this is a massive amount of infrastructure, and we make these fundamental investments in the infrastructure because when you operate at this scale, if you're not making those fundamental investments, those fundamental pieces of innovation in the core infrastructure, you're going to have to pay a lot of money to other people to get anything done. So we believe in really investing in kind of every single aspect of our services, whether it's the coating we put on our special termite Australia cables, or the SDKs that we build for our developers to interact with. So again, we have these 20 regions across 60 AZs. I'm sorry, those numbers are out of date. And we have more than 150 global CloudFront POPs with 89. Both of these numbers are wrong. It's actually closer to 160 and 95 Direct Connect locations. Now, Direct Connect is basically how you can lease a fiber path, or if you're co-located in like Equinix or some other data center, you can say, hey, I want to have a peered connection right into AWS. You can also, if you work for the government, claim eminent domain, and then dig up half of Los Angeles, running a fiber path through the middle of Wilshire Boulevard, and apparently that's legal. And it screws up traffic for everybody for months because you hired the wrong contractors. TMI, I guess. Anyway, one of the other things that we do is we have really, as I spoke earlier, really powerful interconnects. These are 100 gig interconnects between all of our different regions and all of our different AZs. And they go, like I said, across the Pacific. So we had the Hawaii cable that we started working on back in, I think, 2014, and we announced it in 2016, and it's been online since 2017 and been serving traffic. We've got the Jupiter cable that we're working on from Japan to the US, comes online in 2020. The Beta Bay Express cable from Hong Kong to Singapore to the US comes online in 2021, and we're actively pursuing projects in the Atlantic, India, the Middle East, and Africa. Does anybody know what BGP is? BGP is a border gateway protocol. It's a way that we kind of trust implicitly routes across the internet. And one of the reasons it's so important to provide redundant capacity to some of these regions like Africa is that if Egypt gets pissed off at somebody, they can just start publishing fake routes and host their own fake Google, and everybody has to listen to them because there's only one path that kind of gets you into Egypt. That's less true now, but I'm sure you guys have heard about the nightmare scenarios where we just start propagating the wrong addresses. And having more interconnects kind of prevents that from happening. So we're making all of these fundamental advancements to make that happen. So how do you take advantage of this as a customer? How do you take advantage of this core backbone infrastructure? We have something called Global Accelerator, and this provides essentially a global IP. And we publish routes for these IPs across all of our points of presence, all of our edge locations, wherein you can go and you can say, hey, I want the fastest possible route onto the AWS backbone, and then everything that after it hits that IP will transit across our private network, our maintained, our controlled network. So we control everything about it, and that's really important from a security perspective. It's also quite important from an availability perspective. So if you think about the way that things would look before, you would have this, I'm sorry for the jarring color change, but pink is in. And you'll have your local ISP, it'll talk to like autonomous network, and then BCD, whatever, and then it'll finally hop into something that we control. Whereas with global IP, it's your ISP. We're peered with a tremendous number of people, and then it hops over into an AWS region. So I strongly recommend checking out global IPs. It can drastically accelerate the way that, or what is it called again? Global Accelerator. Not global IPs, but I strongly recommend checking that out because it can drastically accelerate the experience that your clients have connecting to your services. All right, how many people have multiple VPCs? Okay, a VPC is a virtual private cloud. This is a software-defined network that basically allows you to publish your own routes, your own ACLs, NACLs, whatever you want to call them, and you can have prefix lists, you can have all manner of different kinds of fun stuff that you want to put into your route table, all kinds of DNS options, all kinds of DHCP options. All of this can be controlled within your VPC, and you can create a IPv6 subnet, you can create a v4 subnet, and each subnet can be associated with different availability zones. Those are the subdivisions with regions that I was talking about earlier. And then if you have multiple VPCs within a single region or even across accounts and even across regions, you can peer those, you can do sharing those VPCs between multiple accounts, and it can become quite complex. Has anybody ever had to manage multiple VPCs, peering, and different subnets and IP prefixes and all that good stuff? Yeah? A lot of fun, right? It's very easy. It's completely trivial to do all the math required to make all of this work together. I just feel really sorry for our network engineers that have to manage all 388 unique fiber paths that we have within those regions. So to make that a little bit easier, we launched something called AWS Transit Gateway. This improves the ability, this is what it would look like before, right? So you would have all these different peering VPCs. You would have to know their subnets and addresses. You would have a VPN connection. You'd have another, internet gateway, a customer gateway for, direct connect or something similar. And it just became complex. You would have to manage a bunch of different routes and devices, and it's much easier to do it this way, where you have one sort of centralized device that is infinitely, well, not infinitely, but within the realm of physics, scalable, and can deal with thousands of gigabytes per second of traffic or terabytes per second of traffic with relatively little concern on your part. So that's Transit Gateway. That was one of the first updates that we announced. And then now I'm going to get into the computing update. So computing, and I apologize for the camera. I'm going to roam a little bit. Thank you. Computing, the way that it works is we think about computing as a spectrum. So it means everything from your virtual private server, which would be EC2, to containerization, which would be something like Docker or ECS or Kubernetes, all of this stuff, all the way over to something called Lambda, which is serverless, if you've heard of this paradigm before. And Lambda is one of the most powerful shifts I have seen happen in our industry in a very long time. So I was around for the relational to non-relational, back to relational, and now I'm around for the shift from regular VPS-based compute into this kind of serverless abstraction layer. And to give you some idea of how quickly this has grown, in 2014, when Werner Vogels, our CTO, announced the Lambda service at his keynote at reInvent, I watched half of the audience that instantly grokked it. They immediately knew what it was going to do and what it was going to be, and they were all very excited. Was anybody in that keynote? Was anybody in the room? It was really fun. It was pretty cool. And then there was the other half of the audience, mostly tech reporters, that were like, why is this a big deal? In 2017 and 2018, no one was asking what Lambda was. Everyone was asking, how can I use more of it? So let's talk about instances first. When we talk about instances, so I'll zoom in on this little square here. We have a pretty wide array of different instance types. We have the T3 instances, which are burstable compute. So this is the ability to go and say, I have a spiky workload. It doesn't need to serve a tremendous amount of traffic constantly. It's going to have to serve a modest amount of traffic for a brief period of time. We have general purpose. We have dense storage. Does anybody run SAP HANA? I'm sorry if you do. Good old Germans. We have the X1 instances and the Z1 instances for that sort of stuff. We have FPGAs, and then we have locally attached disk now as well. So this is NVMe-based SSD storage devices that are local to that server that we're running on, and they're ephemeral, so you get access to them for the link that the instance is on, and then they disappear when you terminate the instance. But this can be really, really good for running services like that needed a really fast SSD cache, so something like MongoDB or Redis and things like that. OK, so we also launched AMD-powered instances. And if you're like me, you were hoping the AMD stock price would shoot up more, but it didn't. But I really am a huge believer in AMD, and I think adding more of these AMD instance types is really, really cool and powerful because you kind of remove the stranglehold that Intel has on our industry, which I probably am not legally allowed to say. We also launched EC2 A1 instances. So these are ARM-powered instances. Anybody looked at the x86 instruction set recently? So x86 is the assembly language that we use for Intel and all of our good friends. And it's massive and bloated, and I think there's something like 12,000 different instructions now. You have separate instructions and pipelines and registers and prerequisites that you have to follow, and the compilers that you have to write to be able to comply with x86, which has gotten drastically overcomplicated. And to the point that most compilers don't even have optimizations for some of the latest instruction sets available on things like the i9 and stuff like that. They've chosen instead to optimize for things like the floating point calculation instruction sets and the AVX 512 instruction sets that are available to the previous generation of processors. But ARM maintains a much more modest, I think it's like 250 set of instructions, and their promise is that they're going to execute those instructions really, really fast and really, really well. So we partnered with Annapurna. We didn't really partner with them. We bought them. And we built our own ARM-based platform, which is an A1 instance where it's built on top of the Graviton processor. And we think this is going to be kind of a game changer for scale-out workloads, so things that scale horizontally. And anything that is libc compatible, you can tell GCC, hey, go compile this and make it work on ARM, and it'll do it. Or Go as well, I guess, supports ARM. Good stuff. All right, so in terms of network performance, back in 2006, we had 1 gigabit per second networking throughout our entire stack. In 2012, we had 10 gigabits per second. 2016, 25 gigabits per second. What comes in 2018? 100 gigabit per second networking. So this is now available to most instances, and the C5N instance type, this is the one that launches with that 100 gigabit per second networking by default, is incredibly powerful, and it's available in a number of different regions, and you basically are able to use SRIOV, or what, I don't know what the correct acronym is, but you bypass the hypervisor and you talk directly to the networking card and you get your stuff done. But to make this available to a larger number of instance types and to make this kind of high-performance computing applications more accessible, we've built a new product called the Elastic Fabric Adapter, the EFA. And this is the ability to add on 100 gigabit per second networking, as well as integrate with traditional messaging passing interfaces. So things like libfabric. And we've got drivers for this that will automatically work. You just mount it on the Windows or on the AWS AMI, which is the machine image, and it will go and run. And my clicker is not working, so just give me 1 second. It is working. OK. And then we launched predictive scaling. So I think a couple years ago, we launched something called AWS application scaling, or auto scaling. I don't know. It's really hard to remember the name. Essentially, what we do is we take the product, the service, and we put the word Amazon in front of it, or AWS in front of it, and that's supposed to be the product. But because everything's so strangely named, I've got one coming up later called Inferentia. I can't wait to talk to you about that one. It sounds like a disease. But anyway, we have this thing called predictive scaling, and this is part of the AWS application auto-scaling service. So if you think about traditional auto-scaling, it was limited to compute, it was limited to databases, and these were all separate things that you thought about. With application auto-scaling, this is something that combines all of the different auto-scaling paradigms into one little accessible console and API. So if you want to scale the number of read replicas that you have on a MySQL database, if you want to scale the read and write capacity units that you have on a DynamoDB table, if you want to scale the compute nodes that you have serving certain network traffic, you can do that quite easily. But one of the things that's difficult in this kind of auto-scaling approach is dealing with periodic elements. And the traditional way that you would deal with periodic elements is you would do a Fourier transform, you would take out the periods, and you would say, oh, during this time, I'm going to have to scale up. But that doesn't really deal with applications that are growing 5% quarter over quarter, or 5% week over week, things like this. The good things, hopefully, when your applications are using more stuff. So you have to use machine learning. You have to use kind of either linear regression or XGBoost or some kind of prediction algorithm that can go and deal with these periodic increases, as well as dealing with these temporary 5% increases and then these huge bursts on things like New Year's Eve. There's a really cool story that Snapchat talked about at reInvent. So if you look up that video on YouTube, you can see how they talk about using billions of transactions per second and how they scaled that on New Year's Eve and during the World Cup. So other updates, these are not really that important, but Hibernation, we have an agent that is, I think, open source that runs on Linux and on Windows that can basically take any workload that's in memory and persist it to disk and then restore it when your instance comes back. And we now support heterogeneous fleets and purchase options, so this allows you to mix different purchase options. Does anybody know what the spot market is? So the spot market is how you can run your workloads for very, very cheap. You bid on the unused capacity of EC2, and you get up to a 90% discount on the cost of a traditional instance. And we have lots and lots of people using the spot market to great effect. With auto-scaling groups, you can now put in different purchase options. So reserved instances, on-demand instances, and spot instances can be mixed and matched to be able to hit your workload. When we get into containers, we have this new thing called App Mesh, which is a service mesh. Service meshes, if you've never dealt with them before, my colleague Robert is going to be talking about those over there. It is essentially a way for your apps to know how to talk to each other and how to persist information between each other without really needing to go and run a bunch of different lookups. And this is an open source project, so if you go to github.com/AWS-labs/AWS-mesh-examples, something like that, you can go and you can learn about App Mesh, and we're developing this in the open, so you can contribute to it now. It's a lot of fun. Way cooler than that is CloudMap. So CloudMap is this, we launched Route 53, which is our DNS service. We launched a subsection of that called Service Discovery back in 2016 or 17. And this is the ability to, either through an API or through DNS, discover connection strings, essentially. So if you think about the way you traditionally talk to a MySQL database, you'll have like a JDBC connection string. Or if you want to talk to some other service, you'll have a connection string that has like an SRV record reference, and then that'll tell you which read replicas and which other nodes you need to speak to in order to talk to your database. And that is how connection lookups have worked for, I would say, the past 7-8 years. And it's a pretty reliable service, especially when you have all kinds of good DNS stuff happening. But not everything is going to talk over DNS. So what we have now is this ability for you to do a dynamic lookup via API or a lookup via DNS. Very, very powerful stuff. And then we have the marketplace for containers, where you can basically take a Docker container and then sell it in the marketplace for other people to spin up and hopefully make some money. OK, so those were the core updates from containers. We also have things like EKS, which is Elastic Kubernetes Service, and ECS, which is Elastic Container Service, and Fargate, which is the ability to run a Docker container without having to provision any of the underlying compute. And this is where we're going to get really fast, because I don't want to take up too much of the time here, because I'd like people to ask questions or kick me off stage. When I talk about serverless, I am talking about the fact that you don't need to worry about your underlying compute. You don't care where and how it's running. You just want the workload to execute. You just want the code to execute. As a developer, it's an extremely powerful paradigm. I can just go and write 30 lines of Python, and now I have an application that's serving 10,000 users globally. Anybody from New York? Well, if you're from New York, there's this thing called the 7 train. It is OK. And I built isthe7trainrunning.com. I used to run it on this service called Elastic Beanstalk, and I had like 40,000 hits a week. It's not that big of a workload, but it cost me, I think, like $8. When I switched it onto Lambda, that $8 went down to, I think, like 8 cents a month, which is so far within the free tier of the service that in the past 5 years, 2014, since 2014, I have not been billed for running this service that people are still hitting all the time. It is a really, really powerful paradigm, and we're doing everything we can to make it easier for developers to get access to it. So what that means is we have IDEs like Cloud9. This is an in-browser IDE. It has Vim integration. Anybody an Emacs user? Don't be afraid to identify yourself. Well, listen, there's an exit over here, and there's an exit over there for all the Emacs users. No, I'm teasing. It has Vim integration, it has Emacs integration, so you can use all the traditional key bindings that you're used to. But people don't necessarily want to use an in-browser IDE. I know I don't. Like I'm Vim till I die, basically. So we added integrations for PyCharm, the IntelliJ suite, and also for VS Code. VS Code is kind of a sleeper hit. I don't know if anybody writes code daily, but I was really down on like Microsoft IDEs after some. Did you know that the entire NASA launch abort system used to run on Visual Basic for Applications Excel macros that talk to a LabVIEW controller? This is a true story. As an intern, they had me rewrite that. And so since then, I've been like afraid of Microsoft IDEs. Excel is an IDE, by the way. And VS Code is not like that at all. It is actually a spectacular piece of technology, and I've really enjoyed using it. So check it out. Something that we have been asked for within Lambda is more languages. So we already supported Node. That was the first language we started to support. Then we added Python, Python 3.7, Java, .NET Core, PowerShell, Golang. And then we added Ruby, which a lot of people were very happy about. But those are the same kinds of people who like Ruby. And then we added custom runtime. So this is the ability to basically run your own code that hits any kind of like HTTP endpoint. And you say, I want more work, send me more work, and we'll send you more work into that container. And then you'll say, OK, I'm done with work, and we'll either freeze the container and take it offline, or we'll keep it up and running, and we'll send you more work when it becomes available. And we already open sourced a couple of those. We open sourced the C++ and Rust custom runtimes, and we had a few partners that developed Erlang, Elixir, PHP, and whatever Insolid is. I don't really know what that is. And also COBOL, because it's 2019. There's a Fortran custom runtime as well, again, because it is 2019. So previously, when you wanted to put libraries in, you would have you would basically build this big deployment package, and it would be a zip file, not much more than that. And you would have to bundle all your libraries together. So there are a lot of popular libraries like Pandas and SciPy and scikit-learn that are kind of large and polluted, and it makes your deployment package very big. And let's say you have a corporate layer, a Kerberos auth layer, or a set of TLS certs that are specific to your application. Putting those in your deployment package means every time you want to update that, you're going to have to redeploy all your functions, which can be kind of a PITA. I don't know if I'm allowed to swear. OK, yeah, it's a pain in the ass to do that. Like, I don't like doing it. So what we launched is Lambda layers, and this is the ability to have kind of all of your libraries and dependencies in different layers, and you can version those, and you can permission those the same way you would a function, and then you can pull those into the various functions that depend on them. And then we added, we launched this thing called the Serverless Application Repository, SAR, and this is the ability to take CloudFormation templates and essentially let other people run with them. We're working on a way to kind of allow people to monetize this and make money off of the apps that they publish in the serverless application repo. And then we added the ability to nest applications, so you can have one application that depends on sub-applications. And then we added support for ALB talking to Lambda. So a lot of people like API Gateway, which is a traditional web interface for interacting with Lambda. One of the ways that we are trying to make Lambda a little more versatile is we put an ALB, an application load balancer, in front of it, which lets you invoke it without having to use an API gateway, because a lot of people want to run Lambda, but they don't want to run API gateway. I know I'm throwing around a lot of different terms here, and I know not everybody is familiar with these. So any questions that you have, I'm going to be done in like 10 more minutes, and I will happily, like, if you want to ask what is AWS, what is the cloud, I am more than happy to answer that question. We also launched WebSocket support for API Gateway. Not going to talk too much about that. Step functions is the ability to orchestrate not just Lambda functions, but a number of other different components. Anything that can talk over HTTP, you can go and you can say, hey, I want you to do some manual action. I want you to do some other thing. This is really, really good for kind of orchestrating data and ETL workflows. We added connectors that apparently don't render correctly in this resolution because I'm bad at internet. For DynamoDB and Batch and ECS and Fargate and Glue and SQS and SNS and SageMaker, which is a service I'll talk about a little bit later, but it is the best. Amazon Legal has told me that I need to stop saying which services are my favorite, but they're not here. So again, we made this a lot easier. One of the things that we launched is another open source project, is something called Firecracker. So how many people have experience with hypervisors like KVM and hopefully just KVM? Anybody had to run Zen? No one's had to run Zen themselves, right? OK, so oh, I'm sorry. We built most of AWS on Zen. It's an excellent service. It's just like getting phone calls at 4 in the morning about security vulnerabilities and having to like figure out embargoes and things like that is always good fun. We launched Firecracker with the help of a number of different principal engineers and senior principal engineers at Amazon, people like Anthony Liguori, who have a cumulative, I would say, 6 decades of experience building hypervisors. These are the people who wrote QEMU, the people who wrote KVM, the people who wrote Zen, and a bunch of University of Toronto graduates. And we built this because we wanted a way to kind of offload a lot of the work of the hypervisor onto a separate card. So we built this thing called the Nitro system, which is its own card that kind of sits off to the side and is attached via hardware to the rack. And that controls all the permissioning, IAM, sandboxing, networking, all this other stuff. And then Firecracker can sit on top of a very lightweight hypervisor and run in thousands and thousands of VMs. Some of the benchmarks that we've been able to get from this are pretty spectacular, and we already have a number of different container providers that have implemented Firecracker as a first-class citizen. If you're interested in virtualization technologies, because it's VTUG, you can check this out. One thing I'll say is we recently reduced the prices on Fargate. This is a containerization environment. That was enabled entirely by Firecracker. So we reduced the prices by 60% in some cases, just because we were able to deal with workloads a little bit better with Firecracker. And the way that it works is it's essentially got a little RESTful API. It deals with its own metadata and where it's running and all this other good stuff. And it can deal with rate limiting and oversubscription. And I could talk at length about this, but we have a lot of other stuff to get to. So in terms of the things that Robert is talking about over in the other room, there's this new concept of GraphQL, and lots of people are using and building things on top of GraphQL. So we have a service called AppSync. But even beyond that, we have a service called Amplify. Again, lots of A words. It's really hard to remember what everything is. I think we're starting at the beginning of the alphabet, and as we add more services, we'll just start going down the alphabet. The Amplify console lets you deploy static websites very, very quickly. So if you think, I want to get started developing, I have a whole tool chain. I want to get started deploying, I have a whole tool chain. It just works with Git. I can do git push. I can say, hey, start deploying this. And if you've ever worked with a static site generator like Jekyll or Hugo or anything like that, you can do that. All right, here's the stuff that's probably pretty interesting for this crew. Security is our #1 priority in the cloud, which is why I'm going to talk about private resolvers first. This is the Route 53 private resolver service. This is something that we launched at reInvent, and this is basically the ability to mix local and cloud DNS resolution. Good fun. We have the Security Hub. This is a place to kind of centralize and see all of your security findings, compliance checks, license checks, and auditing, all that good stuff. It can aggregate from multiple accounts, so it's not limited to just one single AWS account. Pro tip, if you don't already do this, if you ever want to test something out or if you ever want to do something, AWS accounts don't cost you anything in and of themselves, so just get another one, spin another one up. And then add it to your organization, and you can have all the billing go through one centralized account. And it provides a nice unit of isolation in case any of those credentials are ever compromised. So Security Hub is pretty powerful. One thing that I'm really, really excited about is Resource Access Manager. So this is the ability to share services across different AWS accounts. So this could be Route 53 resolver rules or transit gateways and subnets and lots of other stuff coming down the line, including VPCs and stuff like that. We have something called Control Tower. This is the ability to automate that multi-account setup with the best practices that we've developed over the years working with large enterprise customers. So this used to be called landing zone. So if you had an AWS SA that would come into your office and they'd go like, hey, let's deploy a landing zone, this is now that service in one click. So you go into the console, you go to Control Tower, and you say, hey, spin me up a bunch of accounts and do all this good stuff, and it'll do all of that for you, and it'll do all the best practices. We have a private marketplace where you can have internal applications that are built on either Amazon machine images or multiple machine images or containers or whatever you want, and you can allow users of your company internally to launch their own applications that are already pre-vetted and prepared for your infrastructure. And then we have VMware Cloud on AWS. So in partnership with VMware, we've developed this kind of new control plane that lets you use your traditional vCenter and vSphere stuff to talk directly to all of the AWS native APIs and services that you're used to dealing with within the cloud without having to jump across a bunch of different consoles and a bunch of different layers. I think this is going to be kind of a sleeper hit, relatively powerful and useful for people who are migrating from on-prem and more traditional data centers. And if you are using this or have any feedback on it, I'd be interested to hear it. We have lots of different customers that are already using this. And then they asked us to go one step further. And being a very customer-driven company, we did. So we went and we built something called the Outpost. And the Outpost is the ability to basically have AWS on-prem. It's AWS in a data center of your own or co-located or whatever you want. And you have two options. You have VMware Cloud on AWS. That's that API that I was talking about earlier. Or you have AWS native. So this is the same hardware that we run in our own data centers, unless you're in Australia, where apparently we have plastic termite stuff. That still just blows my mind. And you basically get this big old rack, and you get a forklift, and you walk into the data center, slot it in, plug in the power, plug in the fiber, and it just runs. And we will maintain all of the hardware and all this other stuff for you, and we'll give you all of the good stuff that you need to know to make it work. So you have a pretty large group of hybrid options that are available to you now within AWS. So you can integrate all of your on-premise resources with OpsWorks, and this is like Chef or Puppet and things like that, to code deploy, to the Active Directory and IAM and Systems Manager and Direct Connect and VPC and all this good stuff. And you have VMware Cloud on AWS, you have the Outpost. And then if you don't want to go for the full Outpost, we have something called the Snowball Edge. And this is a big ruggedized device. It has like an e-ink shipping label, and we chuck it from Seattle to your data center, and then you plug it into the fiber, and you get a bunch of compute and a bunch of storage. All right, and then we have the well-architected tool where you can define your application. You can say, hey, I have this application. I want to find out if it's well-architected for the AWS cloud or not, and we'll tell you. And then we have License Manager. This is the ability to figure out if you're going to get sued or not. So typically, it's only Oracle that will actually sue its own customers, but IBM, SAP, and others try to help you instead of ruining your day. So if you look at this, you have this console, you define what your license is, and we can look across all the different instances, we can figure out what's running, and then we can tell you whether or not you're in compliance. So, hey, you can even prevent more applications from being spun up because they're going over the limits. And what time does this end, Chris? 11? What? Okay. So, yeah, good stuff. OK, now we're going to get into storage. I'm going to go light speed from this point forward because I think the rest of this is probably not what people care about. So we're going to hunker down. We're going to do this. Everybody ready? OK, this is really hard to do in foreign countries because I speak English very quickly, having spent a lot of time in New York. OK, so we have a number of different storage options available to us on AWS. First is block storage. Then we have object storage, these things like S3. And we have a number of different storage tiers within S3. We have data transfer options. I'll talk a little bit more about those in a moment. But looking at block storage, we have EBS. We, for free, gave everybody a performance boost on their EBS volumes. So these are the IO1, the PIOPS volumes, Provision IOPS volumes. We have the GP2 volumes. These are the SSD-backed volumes that are block storage. And now you get 16,000 IOPS and 256 megabytes per second. Megabytes, not megabits. It's very important, of throughput on a GP2 volume. We also have S3 intelligent tiering. So as I said, we have a number of different storage classes within our object storage system S3. And what happens on that is you have something like infrequent access, you have reduced redundancy access, all this other stuff, and you want to be able to move between them seamlessly. So if you have an object that's over 128 KB, we will pull and see, look at the access logs for that, and we will intelligently move it between the cheapest tier that's available to you. The only cost that you pay is for the cost of scanning the access logs for those objects. Then we have EFS and frequent access. Does anybody use EFS? It's a network attached file system. Basically, people were like, hey, I want EFS, but I don't want to have to pay for as much for it, so we launched this. Then we have data sync. This is basically a VDK that you can launch within your own data center, and it'll talk directly to some of our backplane APIs to be able to put stuff into S3 and other services as quickly as possible. Then we have AWS Transfer for we have SFTP for S3. This is a kind of fun, powerful service. People have been. Does anybody realize that our entire global banking infrastructure runs on SFTP? Like when ADP makes a payroll deposit, they're taking a text file, sending it over SFTP to your bank, and saying, hey, here's a transaction. That blows my mind. It's 2019, and this is still how things work. Anyway, so we launched that. We have lake formation. This is the ability to spin up your own data lake. So a lot of people are telling us that they have trouble dealing with all the different services and all the different, different ways of running your own data lake across Redshift, across S3, across all manner of different things. So we wanted to make a service that would make it kind of one click, make it easier. So we launched that. And then lots of Windows workloads run on AWS. In fact, I think the gross majority of Windows workloads run on AWS. And we launched FSX for Windows File Server. Again, I don't name these things. If you have a problem with the name, you got to take that up with our execs. Amazon FSX for Windows File Server is basically an SMB file store where you don't need any drivers. You have a Windows instance. You say, hey, I want to be able to access this network-attached storage, and then it just works. And it scales, tens of gigabytes per second of throughput with sub-millisecond latencies, and it already has all the good compliances. Launching with PCI, ISO, and HIPAA is not easy. So props to the team. Has anybody ever worked in a high-performance computing environment? I used to work on the Pleiades supercomputer at NASA, and we use Lustre. Has anybody managed Lustre themselves? Did you lose, did you grow gray hair? It wasn't fun. I managed Lustre myself, and I considered quitting technology, moving to the Bahamas, and teaching surfing classes. That was my experience with Lustre. So we will manage it for you, and to the entire team at Amazon that manages all of that, I'm so thankful for you guys. So we also have managed streaming for Kafka, so if you didn't like Kinesis and you wanted to do another kind of streaming service, this is now available for you. We also have Kinesis data analytics support for Java containers or basically .jar files, and you can have integration with S3 and DynamoDB and KDS, and there's a Kinesis data streams, Kinesis data firehose, CloudWatch, all that good stuff, and Flink integrations. Then you have CloudWatch Logs Insights. So this is something that I think might be useful for a couple people in the audience. This is the ability to kind of do a deep dive on your logs with a simple SQL query. So you can write this query, calculate some stuff, and then render a graph. Pretty powerful. And then we launched a bunch of other stuff that's not important. Going into databases. If you think about databases, we have a pretty wide array of databases, and we want to be able to run as many of those as we can. We want to provide as much kind of database capacity and application capacity as possible for every different use case. So if you think about RDS, we have the Aurora database engine. I'll talk a little bit more about that in a second. We have the commercial database engines like Microsoft SQL Server and Oracle, the community database engines like MySQL and Postgres and MariaDB. We have DynamoDB for kind of document key value storage. We have Elasticache with Mcached and Redis. We have Amazon Neptune for graph databases. And to kind of continue the development of RDS and Aurora, we have the multi-master Aurora. It was across multiple regions as well. We have serverless Aurora. We have parallel queries and backtrack. This ability to go to any point in time, any single transaction, go back and restore to that point in time basically instantly. And then we added global tables, this ability to have multi-master global tables across the entire set of 19 regions within AWS. And then we added Amazon Document DB with MongoDB compatibility. This is the ability, people really love the MongoDB query API, so we made it so you could do that. Then we have 2 new services that we announced at reInvent, the time stream database, which is good for time series data, and the quantum ledger database, which is good for #blockchain. If you think about Aurora, this is something that really could only be built in the cloud. This is not something that you could build in a traditional data center. You need that tremendous amount of redundant capacity. You need to really push the boundaries of the realm of physics in order to be able to build a service like this. The way that it works is you have shared distributed storage. You can push as much of the query as possible down to the storage layer. And this allows you to kind of reduce a lot of the traditional replication logic and lag and all that good stuff. We also launched Amazon Document DB. This was actually right after reInvent. And this is a MongoDB compatible database that is fully managed, autoscales to 64 terabytes per cluster, 32 terabytes per database. And we did this because customers were telling us that they wanted another way to run MongoDB in the cloud. And people told us that they were really tired of provisioning capacity for DynamoDB, provisioning write capacity units, read capacity units. What they did is they launched pay per request DynamoDB. Then you don't have to think about capacity. It'll autoscale. You only pay for the requests. And then we launched transactions. So this is a server-side API, very similar to the batch API, where you can talk to multiple tables simultaneously and perform transactions across all of the different things. Time series data is hard. Windowing functions are hard. So we launched the time stream database. Deals with a number of large events. And then blockchain is basically a bunch of people defrauding other people. But we did find a couple of ways that blockchain could be useful, and those are in healthcare and kind of things like payroll. If anybody wants to trust their payroll to a blockchain, it might be more fun than the SFTP approach. And we had a number of customers that wanted to build stuff on that, so we had these 2 different needs. So to deal with those 2 needs, we launched the Quantum Ledger database, which is a blockchain cryptographically verifiable database where you have this chain of transactions that you can go back through. And then we also launched the managed blockchain service, which is Hyperledger or Ethereum, and we'll just manage it for you. It's really not a public blockchain at that point. It's like a private blockchain, which are just words. I don't really get it. So again, lots of really, really cool stuff. OK, moving to the machine learning side. We have tens of thousands of active customers, all doing machine learning. Machine learning is a big deal. It's a very important hype word right now, but it's really, really cool. So just really quick aside, in the few minutes I have remaining, my brother had a heart transplant in 2017, and there was this company called Arteris that I found out was an AWS customer. And I found out they were an AWS customer because when the doctor was loading up the 4-dimensional MRI from Arteris, there was little S3 URL on the status bar, and I was like, hey, wait, stop that. And then I thought about what I was doing, and I was like, no, please continue. Really, really cool stuff. Some of the machine learning that we do helps improve lives for millions of people around the world, and that is really what kind of drives me to keep working on this stuff. And then we also, Snapchat. So it's a spectrum. So when we talk about machine learning at AWS, we're kind of thinking along 3 different paths. We have the core level, the infrastructure. We have the services. This is primarily SageMaker, but also Glue. And then we have the AI services. So these are things like recognition, comprehend, lex, transcribe, poly, translate, all this other stuff. And this is the ability to go out and say, like, hey, I don't know anything about machine learning, but I want to get inferences from this video. I want to identify all the objects in this video. I want to get bounding boxes for them. Or I want to identify all of the images in this video, and I want to get bounding boxes for them. And it's just one API call. So I literally say, hey, API, go figure this out. Give me back a JSON document that documents all this. Then we have the ML services side. SageMaker, I'll talk a little bit more about that in a second, but let's dive into the infrastructure. We want to be the best place to run any kind of framework, so whether it's MXNet or TensorFlow, most TensorFlow workloads already run on AWS. We have a number of different customers, again, Snapchat, they're everywhere. Zendesk, ZocDoc, Siemens is doing really cool stuff on ML with AWS. And then we have these really large new instances, the P3DN 24XL with 100 gigabit per second networking and 64 gigabytes of GPU memory and 768 gigabytes of RAM. And the really interesting thing is everybody talks about the cost and like the power of dealing with training, but training is something that you hopefully do as few times as possible, whereas inference is something that you're serving all the time. So we launched Amazon Elastic Inference, which is the ability to take almost any instance type and attach basically just-in-time teraflops of compute to it in order to be able to serve instances. This is much cheaper than running a giant over-provisioned GPU instance. So this is the ability to add 1 teraflop up to 32 teraflops into any kind of instance that we have. And then MXNet, TensorFlow, and PyTorch already know to talk to these if they're available. So it's much cheaper to do this than to run it on its own thing. OK, and then workloads that need an entire GPU that are also latency sensitive, we launched something that's poorly named called AWS Inferentia. And this is the ability to basically run on custom silicon. It's kind of like our answer to custom silicon for running machine learning workloads. What I will say about this is we have something called SageMaker Neo, which I'll talk about a little bit later, which is the ability to optimize different machine learning models for individual pieces of hardware based on the instruction sets that are available there. OK, moving into the SageMaker. SageMaker is everything from IPython notebooks to built-in algorithms to one-click deployment and inferencing and scaling. Lots of customers using it. We have something called Ground Truth, which is the ability to hire a bunch of interns and have them go and label all your data for you. Or if you don't want to hire interns, then you can use Mechanical Turk or one of our partners. And then we have built-in algorithms. We have marketplace for machine learning where you can take your algorithms, package with Docker containers, and say, hey, I want to sell this and make money on it. And then we have Neo, the model optimizer. Again, this is an open source project that takes MXNet, PyTorch, TensorFlow models and can convert them and optimize them for specific hardware. Everything from like ARM devices to like little Intel Edge devices to M5 4x larges. And then reinforcement learning is a really big topic right now. So reinforcement learning is basically the way that human babies learn theoretically. And you run a bunch of experiments, and eventually you have a reward function, and that reward function says you're doing better or you're doing worse, and you kind of make your stuff better. So we launched SageMaker for reinforcement learning. And then we wanted to help people get better at this. So how do you do that? We have something called Deep Racer. Deep Racer is this league that we're running across all of our summits for the rest of this year where people can go and run a whole shindig and race and have a good time. And then we get into the AI services. So personalization is a new service that we launched. This is the ability to recommend things based on whatever data you have on that person, and you can say, hey, I want to do Netflix for cats. I don't know. That's what personalized allows you to do. And then you have time series data. It's really hard to forecast. As I spoke about earlier, you can't just do a Fourier transform. You have to do a little bit of machine learning. And so to make that easier, we have Amazon Forecast. And then if you think about OCR, that's really hard. So what's even harder is taking the optical character recognition component and then extracting data from that, like the labels for the fields. So we did that too. And then if you think about translation, you have, does anybody speak German? All right, I'm going to assume no. Donau Dampfschiff Gesellschaft Kapitän is like a riverboat captain in the Donau River. And it's a really long German word, and sometimes translation services don't get it very well. So you can add that in. And then we added comprehend medical. So my mother is a nurse, and she told me that if she ever saw a doctor actually charting this way, that she would punch him in the face or her in the face. And this lets you take, doctor's notes or some kind of medical terminology and go and translate it into a richer document, just JSON, where you can go and extract that data and do stuff with it. And it can also identify personally identifiable information and extract that out so that you can use those anonymized records for stuff. And you have glue to glue it all together. And then we have IoT. We launched SiteWise. We launched ThingsGraph. We launched IoT events. This is what ThingsGraph looks like. We have robotic development. Robots are hard, so we made it easier by launching RoboMaker. We have space. Space is hard, so we added a satellite into our region so that people can download across S-band, X-band, UHF, and other stuff data. And then we direct into their VPC. And then all of this is available. These are all the new launches. We talk about all of these live on twitch.tv/AWS. You should follow it and check it out. That was our CTO, Werner Vogels. This channel is very much, a code-first channel. We try and have, real stuff on there and not just talking heads and nonsense and marketing. And in the end, if I haven't bored everybody to tears, please just go play with AWS. Go see what you can build. That's what makes us happy. And if you end up curing cancer or something, please, let me know. Thanks so much.
So we actually have a couple of minutes for Q&A. If anybody wants to stump the chump.
Oh, and definitely follow me on Twitter. I talk a lot about JavaScript. A lot of hate. Any questions? Yes.
Sorry, Jake.
So I'm kind of curious to know where AWS stands right now. I'm kind of curious to know where AWS stands right now in terms of traditional data center-like workloads, such as EC2 and S3 for Object, compared to Azure. I saw a slide that you put up for Windows Compute. I'm just kind of curious where you guys stand right now, and if you have a strategy that you'd like to just talk a little bit about.
You mean in comparison to other providers?
Yes.
I mean, for now, we're still far and away the leader. I expect that trend to continue for the foreseeable future. Everything that I just spoke about were only the things we launched in 1 month in 2018. That pace of innovation is continuous throughout the, everything that we build. I am a little surprised, actually, that it took so long for us to have any competitors, because we started doing this way back in 2006-ish, 2008. And we didn't really have any competition at all until, I would say, 2012. And I'm excited by the competition because it forces us to do better. It makes customers a little happier because we have different kind of workloads building. And as an engineer, it's really exciting to see the differentiated efforts that are being built by the different providers. But in terms of sheer capacity and sheer number of workloads and all this other stuff, I mean, we're an order of magnitude beyond any of the competitors.
Do you have a rough number?
Yeah, I had a slide that had that number. I can go back to it if you want. Yeah.
But this is all of AWS, right? So this slide over here is all of AWS. And by the way, I hope this isn't being taken as a stump the chump.
No, go for it.
Thing. Yeah, because I hate that sort of thing myself.
No, so long as PR and legal aren't here, I can say whatever I want, right?
There you go. I mean, this is New England. You're allowed to swear.
Ah.
So the way I interpret this slide is AWS public cloud market share compared to all of the providers, this is actually pretty consistent with what I've seen. But I'm assuming this includes things like RDS. This includes things such as Lambda, and et cetera, et cetera. I'm curious.
In terms of breaking out the regional services and like what each service contributes in terms of workload and stuff like that, we don't break those numbers out, unfortunately.
Gotcha. So is EC2 and S3 still the largest or amongst the largest services within AWS? Or?
Yeah, like I said, we don't really break those numbers out. But I will say S3 is definitely a very, very huge service. Trillions of objects and billions of transactions per minute. Just tons of stuff coming through S3, EC2 has a similar number of workloads. We have 300,000 individual servers in like one AZ. So, and each one of those can serve multiple EC2 instances. So lots and lots of stuff happening there.
Hi, I'm curious to hear more about the EC2 memory image thing you were talking about
Yeah,
before.
so this is the hibernation agent.
Yes.
This is an open.
Is that integrated with EC2, or is that a totally separate service that I've got to get my head around?
It's integrated with EC2, and it's also an agent that you can run on your own instances. One thing I will say is right now it works very, very well with Amazon Linux. It works okay with some of the other Linux platforms, but for RHEL or for Red Hat Enterprise Linux, you do need to compile it yourself for right now. That's the only caveat that I have. But it's just an agent that runs when you shut down the instance. It persists the state in RAM onto the disk, and then when it boots up again, it checks to see if that directory is there, and then it restores that from disk into RAM. In some cases, yes. On Linux, you can change the instance type. On Windows, I don't know. Yeah. On Linux, you can definitely change the instance type. All right. Shall we let somebody else come on stage and I can go sleep?
Well,
Oh, more
thank you,
questions.
thank
Go
you,
ahead.
Randall, for,
Oh, thanks.
for talking. All right, so we are going to be having lunch served at 11:30, right back behind you guys. A couple of quick items of note. We are going to be starting our own Deep Racer League. So if anybody's curious to join me we've got a couple of Deep Racers. We're not giving them away. We're going to be using them to start our Deep Racer League and try to win that free trip to reInvent this year.
If you want to win, one of the easiest ways to just beat everybody else's time is to just tell the bot to go forward and ignore the lines. Pro tip.
All right, we'll be talking about that later. So hit me up if you guys are interested in doing something like that. That'll be really fun. Lunch in a couple of minutes over on this side. The sponsors are on the other side. They are eager to talk to you, so please go over there and say thank you to them as well. Thanks so much, guys.